So without further ado, it's my pleasure to introduce you Iivo Yrjölä. Is a lead engineer at Prosys OPC, working in customer support and integration with a strong focus on IT and OT integration solution. He specializes in Prosys Forge application, helping customers modernize existing system and design scalable future-proof architecture. Together with him, the Jouni is the CTO of Prosys OPC and leads OPC UA product development as the chief architect of Prosys OPC products. He has deep expertise in interoperable and future-proof industrial connectivity and is a long-standing contributor to the OPC UA ecosystem through the OPC Foundation working groups and Technical Advisory Council. So, Jouni and Iivo, the floor is yours.
Okay, yeah. So we are from Prosys OPC, and in this presentation, I will be showing how you can utilize this Web of Things device onboarding using our application Prosys Forge. And I will start with short company intros. So if there's someone that doesn't know Prosys OPC, which is not like, yeah, so we go through quickly the company intro. Then I will jump into the demonstration itself. I will do that in perspective of end users. So I'm not going to go into detail what kind of stuff you have in the thing description or kind of study the technology itself, but rather give an example how an end user would use this concept. I will give you a live demo of onboarding a Siemens power meter. And in the end of the presentation, we are going to give a short demonstration of other features that Forge has, since Web of Things is just one part of the product. So my name is Iivo Yrjölä. I'm Master of Science from Aalto University. As mentioned, lead engineer at Prosys OPC and working on customer support and integration, mainly regarding Prosys Forge application. And I'm joined here with Jouni, our CTO. Would you like to say a few words?
Yeah, so I'm Jouni. I've worked at Prosys actually at the moment 30 years. So I joined already 1996. The company was established 95. So I'm still a newcomer in that sense. But I've been responsible of the product development here, and we started working on OPC technology very early on, and then worked on building components for different programming environments, and Java became the main platform, and now we also have these end user applications that Iivo will explain shortly. But my responsibility is to run the developer team here, and I'm also very active at the OPC Foundation working groups as the representative of the company. For example, I was involved in the Web of Things connectivity working group that was defining how a Web of Things maps to OPC UA.
Okay, yeah, thank you. So basically that covers quite well also the company slide. So we are global experts on OPC UA solutions, overall also on IT/OT integrations, and giving a lot of focus on industrial security too. Also, we are active members of these organizations, so we are not just developing our own products, but also giving our knowledge for the community to develop better standards and such. And yeah, overall global business that we do. Product family, includes developer tools like Java SDK and Central SDK for Delphi. Now also these production software like Forge, but also simulation and testing tools like simulation server, basic OPC UI server that you can use for testing, demonstration, and learning purposes, for example, and also browser, which is a generic OPC UI client that I'm going to also use in this demonstration for some part, and but main focus will be on Forge. Or just one slide just to gather the focus for this presentation. So I will have this Modbus device, Siemens power meter, and basically for the basic integration, I would need this manual work to understand the registers, read them from Excel file or something, then do the custom integration to Forge. And this would mean a lot of custom engineering and slow deployment. But with this WoT, I don't need to get into the Excel files and understand all the registers, but rather let the devices and machines understand each other and configure the interface automatically. So yeah, I can already tell that with this demonstration, I can see that how this helps with scaling the integration work for much faster deployment. The demonstration will have the following components. So this Siemens power monitoring device that is the data source basically, and we have received this Web of Things thing description from the vendor. So I haven't touched that at all myself, basically. Then Forge, which will be the integration platform where we write the thing description in, and then we are not just going to use the structure coming from the Web of Things, but also we are going to demonstrate how to even enrich the metadata by implementing OPC UA companion specifications on top of the Web of Things. Then I will use browser to show the values and data of Forge. And then you will, well, the InfluxDB won't be too much present, but that is used to history buffering the data. And finally, Grafana is our tool to kind of present the data in the dashboard. This setup will be running on containerized environment. I have the Siemens device here in local network, and also I have a connection to a public internet so that I can access this cloud library, which is OPC UA thing that I will demonstrate on the live demo. And in the picture, it looks like this. So we start from the bottom where we have the Siemens device with thing description. We are able to write that into the Forge, which makes the data available. We will be storing that to Influx just to be able to have the historical access for the data. Then we are going to create the mapping of the data into this energy consumption management information model that we are going to receive from Cloud Library. And finally, we are going to present the data on Grafana. where we have a connector to Forge. And yeah, well, the key points of this presentation are that the onboarding of the device will be very fast, and also when we use the OPC UA company specification, we can add the value for further integrations. Okay, so now I jump to the live demonstration. This is now Grafana dashboard, Grafana user interface. And here we have now the data. So I will first show the end result that we have, and then we are going to jump to the beginning, how to do it. And in a sense, if we look this, yeah, it's nothing too special. Like people have had dashboards all the time. And basically, this is not the fancy part of it, but how we can get to this point, how much does it need engineering work, and all that will be the key point. But before jumping to the beginning, I will also give you a short idea of why the information models will be useful to have and why the context is nowadays extremely important. This window that I opened here is a cloud desktop. And what's special here is that we released a new version of Forge today, and in that we have a MCP server available. So I have connected this cloud desktop to Forge. And if we start looking my prompts that I did this morning, we can see that I am able to just request energy-related namespaces. Yeah, it can find it. I can even just request energy-related devices. And if we take a look to the answer, we can see that it can recognize the device. It can even recognize that it's actually following a OPC UA standard. It finds the different measurements. And yeah, so with this context, I am able to also make the AI understand the data without teaching it any further. And the magic happens in this application, Prosys Forge, that I have running right here. And yeah, at this point, I will now reset my whole configuration so we can start from the beginning. Just like that. First, short intro to Forge. We have a web user interface. So I'm using Firefox to configure Forge. Main navigation bar up here that you can change the different modules in Forge. We have just one installation material that includes all the different features that we have available. So it's a long list already. And you can control the installations and the different modules by license. So you don't need to purchase the whole Forge, but you can just pick whatever features you would like to have and then use the same installation. If you want to upgrade Forge, get a new license and no need to install different components or add-ons to Forge. But to start the demonstration itself, I will look into the WoT module, which I start up now. So we have WoT module running. Then I will jump into the OPC UA client called browser. I have connection to Forge, and here we can do the Web of Things onboarding. So as defined in the specs, we first need to create the asset. Let's call this Siemens Energy Meter 1. call it. And now we have created a new asset. Next thing is that we need to do is to write the thing description. And I have received it from Siemens. It's right here, opened. And I don't need to understand much from this as an end user. Only thing basically what I need to do is to check that the connection parameter IP address is correct, and I have changed it here, and that's now correct. So I can just select the file and say write file, just like that. Refresh this device, and boom, we have the whole device now onboarded to Forge to UA. We can see there is measurements coming through. Let's leave that. So the data is flowing to Forge, and basically this is already the WoT onboarding part. So extremely fast to get data out of it, and the great benefit can be seen right here. So in left panel in the structure, we can see that this is kind of understandable. I means current, so I guess these are different phase like currents that we have. But if I would need to do it from the Modbus registers, I wouldn't understand at all where they are and how to handle. So yeah, but we don't leave the modeling part only to this, but we are going to make it even further with Forge. So next, I want to use these standard OPC UA models. And what I do, I select the model that, let me just quickly hide this for a while. So I will select this one, yeah. And now we get to the cloud library part. So I can see that this information model says that it's also dependent on another model. But because we have the access to the public internet, I'm able to access this cloud library hosting all the other standard models. So now I can just click load, confirm, and it doesn't just load the file that I wanted, but also all the dependencies if they are available in the cloud library. So now we have the models in Forge. We can continue to create some instances for our device. So basically what I would do, I want to have few folders just to create some structure. Let's create under other folder. So kind of ISA 95 style structure, and underneath that, now we want to have an energy meter. So I'll use my energy measurement type. Let's say and just like that, we have created a standard object following the OPC UA information model, having the different energy measurement variables available here. And next we need to connect now the data into this model. That's done by mapping. So I need to do a structure mapping where we connect the different phases into the Siemens energy meter. Same thing for the L2. I will show this later for you, and same thing for L3. So if we take a look from the client side, we see our folders, we see the device, and we have our variable right here. Missing some parameter, of course. Yeah, there we have it. So that's the current P having the measurements in it now from the WoT device. And this way we can now also contextualize the WoT data into UA standard model. And not only we are able to do that, but in Forge, you can also get to create, how to say, additional enhanced data by expressions. So, for example, this active power is not just a one-on-one mapping, but it's calculation of the different variables. So we can still create this by combining the data. So I need to have the voltage data, and now this mapping can be done quite easily since the data is in understandable format. And then we need the current, so this. And finally, we need the power factor to finish this calculation. And then if we look the data through this, we did it on the active, and let's put it here if we are able. No. So we are not only doing one-on-one mapping from the WoT description to the component specification, but we can also use expressions to get more kind of a data, enhance the data. But without going further with these configurations, I will now take restore my backup to kind of finish the configuration. So I will restore my backup from here. It needs a restart. Great. And what we have now here additionally is that we have enabled history module that we can historize the measurements. So this configuration just needs InfluxDB to be running, and then some information from your influx, and then create collector with items. So you just say that, okay, historize this variable, and you will have it in the history. And yeah, so now we have created the complete mapping from our onboarding. So we have the Modbus device onboarded and also mapped to the understandable data, so that it's now easy to understand with the tag names, having the metadata, type definitions, and such. Yeah, and finally, I think I will restart my cloud and see whether we can have a short analysis of the energy measurements. So with the new MCP server, Cloud is able to do historical reads and also browse nodes, get the data out of it. And when we have done the modeling in Forge with using the different information models, having the WoT description, it will also understand the context of the different variables, and it can give you then analysis of the values. So now we can see that it's starting to gather stuff. But basically, yeah, that's the live part of the planned presentation. And then I will jump back to the slides just to quickly go through what else we have in Forge, because it's not just a WoT platform, but in Forge, we have, if we start from the southbound, we have different connectors in Forge so that you can get data from various of sources, including OT devices such as Modbus, Beckhoff, Siemens, but also you can connect Forge to SQL databases to query data. You can read data from files. With MQTT, you can subscribe data into Forge. And then when you have this data available, it will be in OPC UA server always. So we are not kind of a vendor locking you when you get data into Forge that you need to use only our proprietary protocol, but you can still use any UA client to access the data and do the modeling in these global standards. In Forge, you can then also handle the data, like do the different expressions to have additional data, complete your device descriptions with static mappings like tag names and such. And on the northbound, you have multiple interfaces like the MQTT, FREST, nowadays MCP, OPC pops up to deliver the data further. Yeah, so that's basically my presentation. And yeah,